Okay, so now we're going to take a look at example 12, which kind of explains that B to A notation, which makes no sense, right? If we're talking about A being mapped to B, it doesn't make any sense to write it like that until we look at how many potential functions there are. So let's go back to, let's give another example here. So again, we have sets A and B, and we have 3 items in A and 4 items in B. So let's say that we're defining a set. Let's change color here. I'm going to define a set H this time, right? And if we use our one-line notation, since we know the order of A, I don't have to write H of 1 here, or H of, it's supposed to be an H, 2 here, or H of 3 here. It's implied that I'm talking about H at 1, H at 2, H at 3. So let's say that this is going to be 2, 4, 1, which means this maps to 2, this maps to 4, and this maps to 1, right? So this is an example of the one-line notation for the function. If we're choosing the function here, how many potential choices do we have for this first item here? How many places could 1 map to? So if I'm making a new function and I'm going to call this function J, how many choices does J have? Well, it has 1, 2, 3, 4 choices, right? How many choices does J have? So I should probably make it clear we're talking about, I'm going to write 4 choices there so it's clear. How many choices do I have here? Well, again, 2 can map to 1, 2, 3, 4. So I have 4 choices. Remember, it is legal for 2 different values in a domain to map to the same range. It is not legal for 1 value in the domain to have 2 potential values in the range, right? So let's draw this out here. This could point to that, and that could point to that. That's totally legal. What's not legal is 1 pointing to that and 1 pointing to that, which makes sense, right? Given the value 1, there can only be 1 possible output, right? If I have 2 potential outputs, I don't know which one to choose. So 4 possibilities there, and I have 4 possibilities there, which is essentially the size of B. So for each, when I'm making a function, for each item in A, I have however many items in B potential choices, which in this case is 4 raised to the 3, or the size of B raised to the size of A. So that's where that measurement of the number of potential functions comes from. And that's where the notation B to A comes from, even though that's backwards from how we think of it. And that's all they're talking about in example 12. If you have any questions, ask them in the forum below.